Last month, a hyper-realistic fight scene began circulating on social media, prompting immediate concerns from Hollywood studios. The choreography looked so precise that many viewers assumed the entire sequence was generated by AI. The video featured the likeness of Tom Cruise executing perfect martial arts choreography. He was trading blows with a digital facsimile of Brad Pitt. The viral narrative claimed that a filmmaker created this entire sequence using only a 2-line text prompt, but the narrative was false. The footage wasn't generated from a prompt. It was a digital layer applied over a traditional film shoot. Underneath the digital faces was a physical green screen set. The production relied on professional stuntmen, specialized motion capture tracking suits, and traditional choreography to sell the movement. The AI model, Dance 2.0, acted as a final style filter and face swap tool rather than a true text-to-video generator. Professional AI video in 2026 still depends on manual labor and traditional production scaffolding. The magic text prompt is a marketing myth. The reality of the shoot didn't stop the legal fallout. Disney and Paramount issued immediate cease and desist orders against the developer, ByteDance. Studios are responding to the fact that this technology makes it easy to ingest and replicate copyrighted characters. It allows users to create high-fidelity pirated content with unprecedented speed. These disputes forced ByteDance to pause the global launch of their flagship video model while their legal team reviews the tool's capabilities. The technical feature driving this risk is multimodal control. Multimodal control is an AI architecture that allows a user to direct a model using a combination of text, images, video, and audio simultaneously, rather than relying on text alone. For a brand, using these tools without understanding their legal vulnerabilities can lead to a campaign being pulled overnight. Success in the current landscape requires evaluating generators based on their specific architectural workflows and legal safety. This brings us to Dance 2.0. ByteDance identifies this system as a multimodal director, prioritizing strict control over the randomness of typical AI generators. The quad modem engine processes 4 distinct data inputs: text, images, audio, and video, producing a single video output. This architecture allows creators to lock in exact character identities and camera movements. Referencing existing assets ensures the character looks identical across every scene. This approach serves professional marketers and brand strategists who need to maintain strict asset consistency. The trade-off is the effort required. Achieving this level of control demands significant upfront work to prepare and legally clear all the reference assets. Dance 2.0 provides rigorous, enterprise-grade control at the cost of spontaneous creativity. OpenAI's Sora 2 uses a different approach, centered on world simulation. This model prioritizes the calculation of physical laws, like gravity and light, over matching a specific reference image. Sora 2 calculates fluid dynamics and object permanence naturally. Shards and liquid move realistically based on the exact point of impact. Filmmakers and VFX artists use this engine when they need realistic environmental B-roll or cinematic establishing shots. The primary drawback is character stability. Generating the world from scratch makes keeping a character identical shot to shot difficult, and the compute costs are high. Sora 2 is a powerful engine for physical realism, but its lack of strict input control makes it difficult to use for character-driven branding. A third option for the 2026 market is Kuaishou's Kling 3.0. Kling's technical focus is on a motion brush feature. This allows users to dictate paths for complex, organic movement directly on an image. This shot shows its ability to prevent common AI glitches, like morphing bodies or spaghetti limbs, during rapid human actions such as dancing or athletics. Social media creators use this model to maintain high-volume output for platforms like TikTok and Reels. Users sacrifice high-end cinematic lighting and the standard 24 FPS polish, the frame rate used in traditional filmmaking, for the sake of speed and lower costs. Kling 3.0 prioritizes motion and budget, making it the primary tool for volume-heavy production. Selecting a model requires looking past which tool is best and identifying which architecture fits a project's specific friction tolerance. This quadrant chart maps the current market landscape. We have creative control on the y-axis and physical realism on the x-axis. Cadence 2.0 fits the high control quadrant, making it a viable choice for brand consistency and intellectual property safety. Sora 2 sits in the high realism quadrant, serving as the standard for visual effects and cinematic world building. Kling 3.0 occupies the center, balancing architecture and cost for high-volume social media content. Investing in the wrong quadrant for your project goals leads to wasted budgets and broken workflows. Despite viral claims, no single AI model can produce a finished narrative film on its own. The actual 2026 pipeline involves generating specific raw assets in these tools and then stitching them together in traditional editing bays. This video represents that forward momentum. Creating in this environment requires moving from passive prompting to actively directing and assembling a cohesive timeline. The professionals who succeed in 2026 will be those who look past the hype, understand the underlying physics of these tools, and embrace the multi-tool reality of modern production.